Find a light one. Just let me know.
You lost one?
Yeah, I lost one. Like during what year? Or like...
It'd be, so the answer would be what year? Yeah, during what year would it hit 40 billion? Yeah, and that is an important thing in any story problem, is always to answer the question that is asked.
On that graph, was the left side the money?
Yeah, so S is the billions spent, and T is the year. So T equals 0 would be 2,000. So yes, so this would be like your Y and your X, right, on your equation. All right, what do you got? 13, 2013. Okay, so let's see what that would look like. Basically, you have two, if you're given the model, if you're given the equation, whether it's a log or exponential equation, you basically have two different things you can do. If you're given the input value, if you're given the t value, okay, for example, another question could have been, what will the advertising, how much will be spent on advertising in 2011? Right? Well, what would you do to figure out the advertising spent in 2011? You plug an 11 in for t, right? And then all you have to do is work out the right side. You're not solving anything. You're evaluating the expression. So you would put an 11 in for t, and you just type in your calculator, 10.33 times e raised to the 0.1022 times 11. Make sure you put parentheses in where they need to be and everything. And that would give you S, that give you spending. So one thing is they give you the input, you just type that in, and you get the output, okay? The one where you have to solve is when they give you the output, right? They give you the output and ask you for the input. So they give you the 40, which is the S, which has to go over here. So the bottom line is then, in solving log and exponentials, what we talked about last week is you want to get the log or the exponential by itself. And so then you can convert forms, or in the case of an exponential, we can take the log of both sides. Now, here I converted forms. Now, I told you I liked it by default, just do log of both sides. I do ln every time I do log. You can do log base 10, you do log log, or you do ln log, right? Either one. You do any log you want, but those are the two on your calculator. Okay? So you put a 40 here, now you got to get the exponential by itself, so you got to divide by 10.33. So you get that. Once you get to here, now, I could take the ln of both sides. Now, I said by default, I usually do the log of both sides. Now, that's not really true. If I've got a pretty easy exponential setting there, especially one that's got e, because I like to use ln, and that's base e. To be honest, I would probably, on this one, I would just convert forms. So this one, convert it to log base e, which is ln, of that, equals that. Remember, it's always this base, e, raised to this, that equals that. Okay, so you turn it into that one now, it's pretty easy. Now you're just going to divide by 0.1022. So take that LN divided by that in your calculator, 13.24. So that's 2013, sometime during 2013. Okay? Now, here's what it would look like if right at this step, I would have done the LN of both sides. If I had done the LN of both sides, it would have looked like this. Then what can you do with this power? The whole point of doing the log of both sides when you have a power is that you can bring that power down in front. That's one of our really important log properties. I can bring this power down in front, and then ln of course, is just 1. E raised to the what makes E raised to the first. ln is just 1. And then I get the same thing. Then I get to the same point I was right here. Okay, but converting forms, I kind of get there in one step. Here, it kind of takes a couple steps, right? I mean, so that's why if it's pretty simple exponential, especially with an E, I'm probably going to do that. All right, let's try this one. Okay, you got 5,000 students on campus. That was just a basic exponential growth kind of problem. Oh, by the way, I was going to, on Desmos, so in calculus, we have graphic calculators that will graph and actually will solve as well. But basically, you're looking for this right here. You're looking for this intersection, right? And so, if you're working with a, software like this, it's really nice. Where does this graph equal 40? Where's the output equal 40? Well, you can graph the line y equals 40. Where's the output 40? And you can find the input right there, right? Which is what we have. So when you have access to something like that, that's nice. But we're going to solve it algebraically. So for our test, we're not going to be using that. We want to work it out this way. Okay? All right. So 5,000 students on campus. Y is the number of students that have contracted the flu T days after the initial report or the first person has the flu. So T0 would be, the time when there's one person with the flu. Okay? So 2 questions. How many people have the flu after 5 days? Okay, here's the equation, by the way. Y is the number of people with the flu. T is the time. So how many have the flu after 5 days? Go ahead and do that. What do you got? Now you just got to remember to put parentheses in the right place. You get your 5,000. Maybe just do the bottom first. Write that down, then do 5,000 divided by that, or do 5,000 divided by, and then put everything in parentheses. So just make sure you type it in correctly. But 54. Okay. So all you're doing is you're just putting a 5 right in there. Putting a 5 right in there for T. Okay. And there are 54 people after 5 days. Okay. All right. Now. This particular college, if their rule is if 40% of the people, 40% of the student body gets campus, they will cancel classes. Okay? So how long will it take for 40% of the population to be infected? Do that. You can help each other out a little bit if you want to. Ask around.
wrote it up, she did exactly what I wrote.
Okay, so then you have to take your 1 plus 499, you can take that all times 2,000, so it's 2,000 plus. It comes out to be 999.8000 e to the negative 0.8.
All right, what do we got?
Rounded up to 11, so.
To 11?
I rounded up to 6.
It's like 10.1.
Yeah, I did a whole day.
I got you. So on the 10th day, there wasn't quite that many, so it wasn't. That's fine. I'm not going to get that big. Okay, so let's look at what's involved here. Now, when you get in with these big numbers, if you're a little bit creative with your algebra in what you divide at what times, you can save yourself a little bit of headache. So in other words, we're trying to get t by itself. Well, we first have to get the exponential by itself, right? Now again, that's rule number 1 in these exponential or log equations. Get the log by itself, get the exponential by itself, so that you can then convert forms and then go from there. So I need to multiply this whole quantity over here. Now I could multiply that and distribute the 2,000, and then I get this really crazy big number in front of here. And I think it's better if I just leave it 2,000 times 1 plus 4,999 e to the negative 0.8t equals 5,000. Just divide this whole quantity over here and then divide the 2,000 over to that side. Or think of it like that, like a cross multiply thing, right? And you know what you do with something like this is you take this times this and you divide by that. Let me do that again. This times this and divide by that is going to equal this down here. That's another way to think about it. So this is going to equal that times that and then divide by that. Okay, and so that's where this 2.5, when you divide the 2,000 over here, that's where this 2.5 comes from. Then you can just subtract 1 and get that. And now you've got to, don't forget, you've got to divide that 4,999. Okay, so you divide the 4,999, you get this. And you should save a whole bunch of those decimal places in your calculator. Okay, and I'm going to want you to write down some of these steps when you're doing the problem, showing your work, because that's how you get partial credit. Now, once we're here, now we can just change that to the log form. And it's base e, so ln works perfectly. E raised to that makes that, so it's log of that equals negative 0.8t, and then you can divide by negative 0.8. So you just do ln of this, divide by negative 0.8, 10.1. Roughly 10 days, you could say it on the 11th day. By the 11th day, it'll be that. That's fine. As long as I can see your work and where you're at. That's good. Okay, so now those are both exponentials. Now, by the way, this has a name. This is called the logistic function, the logistic equation, and it's kind of a cool scenario. If we look at it here, it is okay. It looks like this, kind of an S-shaped. It starts out with an exponential kind of shape, and then it turns into more of a log kind of a shape at the other end. And it's a pretty famous type of graph. It's a population. A lot of times you use population growth for exponential growth, but that's unlimited exponential growth. It's not going to grow forever and ever like the population of the Earth. You know, at some point there's what you would call a carrying capacity. It can only hold so many, and that growth will start to level off. In biology, it's a well-known in a certain region, in a certain area. We used to do this. I guess the calculus test we talked about this, but if you had a certain population in an area, you know, mice or snakes or I don't know, whatever, you know, population may grow fairly fast, but then they start to overgrow the area, and they run out of food, or they, you know, disease or whatever kind of things happen, and so what you have is they level off, and that's kind of called the carrying capacity. Well, in this case, the carrying capacity would be the 5,000 students. You know, you can't have more than 5,000 students get the flu here on a 5,000 student campus, right? And so the idea is it would start pretty quickly as more and more people get it. In the beginning, it's slow because not very many people have it. But as more and more people get it, it starts growing pretty fast. But then why does it have to slow down? There's not many people left to get sick. Most people have it, right? And so there comes, and this point where it's going the fastest is called the inflection point. And the inflection point is the part where this graph's the steepest, and that's the part where it switches and it starts to level off the other way. Well, anyway, we were trying to find when this would equal 2,000, okay? So that would be right there, which was the number we found, 10.139. Now, it's also kind of interesting to just think about the equation. This is, again, another calculus thing, something you do called limits, okay? Well, you'd use it with horizontal asymptotes, because that's really what you have. There's a horizontal asymptote up there at 5,000, and another one down here at 0, okay? And so let's think about that. When t is really small, at the very beginning, when t is near 0, this becomes e raised to the what? When t is 0. E raised to the 0, which is 1, right? And so the bottom is 1 plus 4,999. Well, that's 5,000. You have 5,000 divided by 5,000. That's one person. One person had the flu at time 0. Okay? So this number is pretty big. When this is small, when t is small, then this number is its biggest. But what happens over time? As time gets bigger and bigger, well, think about this. This exponential right here is, since it's negative, that would be the same as 1 over e to the 0.8t, right? Negative power means flip, right? So as t gets bigger and bigger, this is 2.718. So what happens of 2.718 or e raised to a bigger and bigger number? What's that bottom number doing? Getting bigger or smaller, that bottom number? Getting bigger, right? The bottom of that fraction is getting bigger and bigger and bigger. Well, what happens to a fraction when the bottom gets bigger and bigger and bigger? It gets smaller, and 1/10,000th, 1/1,000,000th, 1/1,000,000,000th, right? So this is getting smaller and smaller towards 0. So this whole thing is going towards 0, getting very small. What happens when you take a really small number like 0.00000 something times this number? That gets small also, right? You take a really small number, 0.00000 something times this, it gets very small. So this whole piece here goes towards 0. What's 1 plus a really, really small number? Well, no. No. What's 1 plus a really, really, really small number? Basically, 1. It's 1 plus 0.00000 something. That's basically 1. So the bottom is, so as t gets really big, the bottom is essentially becoming 1. And what's 5,000 divided by basically 1? 5,000. So what's happening is, now it's not quite 1, it's 1.00 something. So if you take 5,000 divided by something just a little bit bigger than 1, you get something just a little bit smaller than 5,000. Right? 5,000 divided by 1 is 5,000. But 5,000 divided by 1.1 would be a little smaller than 5,000. Right? So you can tell that on this end it should be going towards 1, the one person, 5,000 divided by 5,000. And as time goes on, it's going to cap out at 5,000. Okay, this number on the bottom can't go below 1. So it's going to be 5,000 divided by essentially 1. Okay, and so it levels off. That's called the logistic function. Okay, let's talk about one more type of equation. So there you've had practice doing solving two exponential equations. Okay, let's do this one right here. Okay, so write that one down. Okay, so this is one of the worksheets that you're going to work on here a little bit before lunch, and then, well, it depends. We got a little matching activity we're going to do, and then you'll have the whole time after to work on these worksheets. It's quite a few problems, but like I say, you get a lot of work done. And a lot of them are very similar, and so they go pretty quick, and so you get just the basic skill idea. What are you going to do first here? Any ideas? There's really two routes you can go here. And either route will get you where you want to go. Add the log 5x to the other side. That's one option. What would be the other option?
Couldn't you divide by log the base of it? Just get rid of it?
After you add it,
Yeah, after you add the log over there. Okay, but what's the other route? What do we know about logs that are subtracted? That's a quotient, right? So you got an option here. I'm going to write them both down. So one option would be to turn this into a single log, like this, right? And the other option would be to write log base 7 x squared minus 6 equals log base 7 of 5x, right? Just to add that log over there. Okay, now the one on the right, what would you do here? Is this what you're talking about now? Don't say divide by log 7, because that's awful. Because that's not what you're doing. Okay, yeah, well, I'm just being serious, right? That's not what you're doing. What are you doing? What was that property called? We've mentioned it a couple times.
One-to-one.
The one-to-one property, right? The one-to-one property, okay? That's what you're doing. If log base 7 of this is equal to log base 7 of this, then the thing inside there has to be the same as the log inside, as the thing inside here. So yeah, because if you start trying to divide by logs, I mean, that'd be like doing this, like sin x equals 1/2. We know the answer to that is pi 6. Hopefully we all remember that. We'll need to on our finals, but that's another story. But Seth's plan here would be to divide both sides by sin, I guess, and he would have x equals 1/2 like that, right? Divide both sides by sine, and then you get the x by itself. Well, that is no good. That's awful, awful, awful. Okay? So we got to make sure we're not thinking about doing that. Okay? So, yeah, how you want to say it? If you want to say just drop the logs out, or use a one-to-one property or whatever, just don't say divide both sides by log 7. Okay? Now, what about here? What would you do over here if you were doing it this way? 7 raised to the 0 equals this. In other words, you've got the log by itself now, and so let's convert forms. And so 7 raised to the 0 equals x squared minus 6 over 5x. Right? Well, what's 7 to the 0? That's just 1. And so now what can we do here? Multiply the 5x over to that side, and notice we're now at the same exact spot no matter which way you did it. Okay? So add the log over to this side, and then notice with the one-to-one property you have that, or condense them using the property that we had with subtraction, and then convert forms. Okay, what do you do from here? This is where just basic algebra 2 comes in, which would be to gather the terms to one side, which would look like this. Okay, now this one happens to factor. It's possible on our test you might have to do the quadratic formula. I'll probably put it on the board for you if you can't remember the quadratic formula. But chances are that it'll probably be a factor kind of a thing, like this one is. Now, what do you got here?
Minus 3, minus 2.
No?
6.
Minus 6 plus 1. Minus 3 minus 2 would give you plus 6. Okay, so it's got to be minus 6 plus 1. So x equals 6 or negative 1. Okay, so if you avoided all those pitfalls that we just talked about, and you get down to here, you feel pretty good about yourself, well, guess what? You're still wrong. Okay? You're still wrong. Because there's one thing that we talked about a little bit, but maybe haven't had one. You might have had one in the book problems. Nobody asked about it. But with log equations, you have to remember that when you have any kind of a log, what do you know about what has to be inside those parentheses? It's got to be a positive number. You cannot have 0, you cannot have negative. So once you get your, now that doesn't mean x can't be negative. It doesn't mean we're going to throw out the negative 1 just because it's negative. The inside of the log can't be negative. So you have to check these answers. So put a 6 in here, that'd be 36 minus 6, that's 30, that's no problem. And put a 6 in here, 5 times 6 is 30. Okay, log 30 minus log 30 would be 0, that works. Put a negative 1 in here. Negative 1 squared is 1 minus 6. Negative 5, that doesn't work. 5 times negative 1 is negative 5. Now you might say, oh, log negative 5 minus log negative 5. No, those are both undefined. Those don't have value. So an undefined minus an undefined does not equal 0. Okay? So we have to throw out the negative 1. And the only answer to that is 6. That could happen on the test. Most of the time it's not, but it may. And so you need to check whenever you're doing a log equation. The exponentials aren't, that's not going to happen. The exponential equation, you have something raised to an x. You can put anything you want in there. The domain is all reals, okay? But not with logs. Okay, partner up here and grab one of these sheets or whatever groups you guys have been in. Little matching with some equations. Match the number with the letter.
I'm running out of paper real fast. Are we turning this in?
Yeah, right here. Here's, hey, everybody takes one of these. We're going to turn it in. So you got numbers down the side. There's 22 numbered. Some are equations, some are answers, some are whatever. You match them with the letter. And then just put the letter in the blank. Should be enough here for every group. Every group turns one of those in. When we get done, if you get done before lunch, there's 2 worksheets up here on this book. One is exponential, one is logarithm. There's front and back. It's only about 50 problems.
What?
It's just about 50.
Just about?
Oh, it's exactly 50.
Even better.
Yeah. And the answers are up here if you want to need to check. Football.
Some people want to say championship.
Oh, I know that.
Yeah, you wouldn't want to come.
There's a